Hello there. You might be thinking that in order to improve or basically have the security implemented in your application, we only need to do it on the backend, on the server side. However, the reality is that we need to take this aspect into consideration for both backend and frontend. So that's why I decided for my today's talk to talk a little bit about the security in Vue and Nuxt applications. My name is Jakub and I'm a senior full stack developer at Vue Storefront. I will talk a little bit about Vue Storefront in the next slide. So right now I will focus on the next icons here on this slide. So apart from Vue Storefront, I'm also a Google developer expert in web performance, quite recently, last year actually. And I'm also an ambassador for Nuxt, Algolia, Storyblock, Cloudinary, and Supabase. So if you would like to talk more about these organizations, these tools with me, make sure to send me a DM at Jacob Andreski on Twitter and let's build something cool together. So Vue Storefront, what is Vue Storefront? Vue Storefront is a lightning-fast front-end platform for headless commerce. What it means is that basically we at Vue Storefront are helping companies migrate into modern e-commerce architecture, which is based on headless commerce and composable commerce, where our e-commerce application is basically composed out of several different third-party services, such as headless CMSs, e-commerce platforms, or search engines. So if you are interested in learning more about Vue Storefront, check out our portfolio page, documentation, or GitHub for our open source projects as well. I created this quote, let's say, that after this presentation, you will be a security ninja. Yeah, because this is the title of this presentation. Let's talk about security. So basically, after this talk, you should be like security ninja. However, the reality is that it is not possible to become a security ninja after just one talk. So I decided to make this talk with a different mindset. So instead of trying to teach how to be a security ninja or security master, basically to be more aware of security risks that can appear in modern web applications. Because actually there are many of them that we should take into consideration while developing modern web applications. So in this talk, I would like to guide you and show you some resources that you can use in order to be more aware of the issues that you can encounter while developing your web application. So I will start with something that I'm using almost every day, which is OWASP Top 10. So OWASP Top 10 is a standard awareness document. Keep in mind this awareness, it will be in other slides in my presentation as well, for developers and web application security. So in simple more words, it is just a document that lists the common issues and common security problems that are quite frequent in modern web applications. Yeah, as it shows, it represents a broad consensus about the most critical security risks to web applications. And OWASP Top 10 is also recognized as the first step towards more secure coding. What it means is that it is not like a solution that will solve all of your issues in terms of security. It's more like it is a first step that you can use every day to just make your application more secure. So how OWASP Top 10 actually works? As I mentioned, it is a list of the common issues, common web application security issues, and it is constantly updated. This is not like a list that was developed 20 years ago and it is in the same format as it is today. It is basically evolving based on the popularity of certain issues. So as you can see here on the left, you have the 2017 edition of OWASP Top 10, where the top security issues were injection and broken authentication. However, if we compare it to 2021, the actual first and two places are broken access control and cryptographic failures. So this means that each year or each few years, we need to actually refactor our approach to handle the security in our web applications. If we could dive into the actual issues and risks that are listed here, let's say this A01 2021 broken access control, what we would get is we would get much more details into what the actual risk is, how it is usually appearing in your web application, how you can fix it, or basically what tools you can use to fix it. Because in some cases, you can use external tools or packages, for example, for Node.js to mitigate those issues. And there is also something that I use quite frequently, which is OWASP cheat sheet series, where basically OWASP created those checklists or cheat sheets where you can just have the most important information about the security risks. In this case, I'm displaying the Node.js security cheat sheet that basically covers the most important things that you should cover while developing Node.js application. Because if we go back to here, in here, this is more like a general application security risks, not only related to Node.js applications. However, in here, you will have a more detailed approach to develop secure Node.js applications, with the examples of packages that you can use with in your next in Node.js application. However, the approach will be exactly the same. So you have all those most important or most frequent security risks and basically how to handle them in your Node.js application. So let's actually take a look at some of the most frequent security risks. I selected few of them because there are actually many of them, so I just selected few of them that I like the most. So we have the ones that are injecting something. So let's say cross-site scripting and SQL injection. SQL injection is actually quite an old injection method that you might be thinking that doesn't exist anymore. However, you will be surprised how many websites still are affected or can be affected by this malfunction. So how it works is that instead of a regular SQL query that we are sending to the or we are actually using on the backend, the server side, what is happening is that because of the text that the user is sending from the client side, from the browser, that can contain some sort of SQL query, what is happening is instead of just, let's say, selecting some value from the SQL database, we are actually injecting some data into SQL, as you can see in the example on the right side. What is happening there is that the user can actually insert some data, insert some malicious data into our database, or get or fetch the data that he shouldn't see, let's say the list of all users. So this is about the SQL injection. In terms of cross-site scripting, how it works is that from the client, we are actually sending the JavaScript code as shown here. As a text, we are sending script alert1. This script, this string is then saved in the database. And then once another user will be fetching the same result from the database, what he will get is he will get some data about that was stored in the database. And also he will get the string where this JavaScript code is, which means that it will basically be executed in this client or in this user browser once fetched. So you can already see like issues that can appear here. Another one I mentioned quite frequently, which is broken access control. And this is the one that is particularly interesting for both backend and the frontend. So how it works is that user will be fetching data about, let's say, himself from the server and from the database. So when handled correctly, this user should see the data about himself, right? His name, his phone number, stuff like that. However, if this access control is not implemented correctly, it's like broken access control, a person without correct access can access the data as well. So let's say that our friend can access the data about, let's say, me. It shouldn't be done like that. Yeah, so it can be done it should be done on the backend. So the backend should secure that only a user that can actually see the data should receive this data. And also on the front end, because imagine that we have, let's say, some pages or routes that are only meant for, let's say, super admin or the admin role. We shouldn't be displaying them to even the normal user. This can happen if someone knows the structure of our endpoints or our routes in the front end. And let's say that we have our website and we will go /admin/create something or delete something, even worse. So the user might not be able to then execute any functionality, but he will already see how the admin functionality works or looks like. So because of that, we should take this access control into consideration both on the backend and the frontend. And the last one, which is about the denial of service. So we have actually two of them. We have DDoS and DOS. So DOS is denial of service. However, DDoS is distributed denial of service. So how it works is basically we have a server where our application is running. An attacker is using multiple so-called zombie devices to send requests to our server, which causes the server to basically stop working because there are too many requests and the server basically cannot handle them. As a result, the server is just failing, like stopping working, and we have to restart it again. And there is also one bonus case that I wanted to show you. Unfortunately, so the bonus case is about malicious NPM packages, sometimes called dependency confusion. And I said unfortunately because unfortunately I have only the article about this. I have found an article about this particular attack only in Polish. However, I'm sure that you will be able to find some of them in English as well. So how it works, this attack, is basically that some of the hackers tried to publish the packages, the NPM packages, for the packages that are usually like enterprise, from big companies such as PayPal, such as let's say Shopify, Netflix. So they put them into NPM with the names where it suggests that it can be delivered by the official company, but it's not actually. And in the end, what was happening that they created those packages, let's say of PayPal. And inside this package, what they were doing is they were doing something what is called the reverse shell. So in short words, they were basically taking control of your device because of the fact that you have installed the package that they created and you thought that it might be, an open source version of the enterprise package of a big company. So it might sound strange and very difficult to catch. So the guy who found this bug in a bug bounty managed to get about $130,000 for this bug. So it's quite huge amount of money for such a even simple bug. However, if you take a look at the list of the companies that were affected by this kind of issue, it was PayPal, Microsoft, Apple, Shopify, Netflix, Tesla, or Uber. So basically quite big companies. So how can we make Vue apps more secure? We can use the official best practices page from the Vue documentation about security. It's quite good source of knowledge about making the application more secure. And we can also go for HTML5 sec, which also gives you some insight on what you could do with your application to make it more secure. And what about Nuxt? So Nuxt is a bit different because in Nuxt you can have a server, because you can have server-side rendered application. So I would recommend you to try it, Nuxt Security. And Nuxt Security is the module that I created for Nuxt a few months ago. And I've seen that the popularity is quite growing, so this is a really demanded functionality. So what this module does for you is that it adds the security response headers, the ones that are recommended to make your application more secure. If you are coming from Node.js/Express world, you might have heard about the Helmet middleware. So this one actually works exactly the same. You also have the content security policy for SSG apps. So this module doesn't only work for SSR, it also works for SSG apps. You have things like request size and rate limiters. So the things that should help you handle issues with the DOS attacks. You have cross-site scripting validation, basically protecting you against the issue that I showed a few slides ago. And you also have support for CORS. And optionally, because other things are enabled by default, but optionally you can also have the allowed HTTP methods, middleware, basic auth, or CSRF. So the module is publicly available. It's open source. So after this presentation, if you find something that should be working a different way, or maybe there's a security recommendation that you could basically recommend or maybe even create for the module, make sure to check out @Barosian/Nuxt Security. And also, if you like this experience, make sure to also leave a star. Yeah, so now on to demo time. Okay, so let me just close it for now, and let's go to Nuxt security documentation. So you've seen this page already. However, what I wanted to do right now, because I have the application, Nuxt application running here in the background. It's currently on Nuxt 3.4.3. This is the most up-to-date version when I'm recording this. So I will just run the server with yarn dev. And I will go here to just show you some things. So we have the Nuxt welcome page. And when we go to the network tab here and we refresh the page, in the localhost here, you will see that the response headers, we have only like 6 of them. So we have the access control, allow origin, we have export by, basically only 6 of them. So what I will do right now is I will copy this command. I will stop the server and install right now the Nuxt security module. Okay, so it was installed, version 0.13. And what I will do here is I will add here to the modules array in the Nuxt config, Nuxt security. Okay, let's run the server, yarn dev. And what will happen right now is that when I will inspect this local host, you will see that we have actually many more response headers here set, and all of them are related to security. So we have the rules for downloading options, for permissions. I will talk about permissions in a second. And we will have cross-origin opener policy, resource policy, and actually the content security policy. So this is being done by the module automatically, so we don't need to take care of that. If we take a look at the get started, we already did all of that. So let's go to, let's say, XSS validator. How it works is basically whenever we will send from the client to the server, to the underlying Nuxt server, we will send a text or a value that will contain some unsecure keywords such as script, alert, things like that. This middleware will basically stop the request. So let's try it right now. I will close it for now. And in here, what I will do is I will create a parameter called text. And inside, I will go script and we'll go alert1, something like this. And in here, we'll go script. You need to close it properly. So basically, a script that will show an alert. If we press enter, what will happen is that we will get 400 bad requests. This XSS validator middleware basically blocked the request so that it doesn't go to the server and it doesn't basically ruin our application. So this is about XSS validation. Let's go to maybe rate limiter. So how rate limiter is configured is basically after 200 requests that are coming from the same IP address, it will block any other requests, and the same IP address will be able to make more requests the next day because the interval is set to 1 day. So what we'll do right now is I will just copy this, the configuration for rate limiter. I will go to the code, and then in here I will paste this. No worries about the TypeScript. This is will work. So we have rate limiter, we have tokens per interval, and I will set them to 2 instead, just to show you how it works. Interval can be, let's say, minute, and this is not needed, and this is not needed as it can stay. So what will happen right now is we will try to go to the homepage multiple times to see if it works. And you see, after certain amount of requests, we get 429 error that shows us the message too many requests. So now I could access this website once the interval will be fulfilled. So after a minute or whatever. Going next, what we have? Let's say we want to implement basic auth in our application so that we can only access the application if we have the correct name and the password. So I will once again copy this code here, go to Nuxt modules, and in this I will go and test enabled true and the message test. So what will happen right now is if I refresh, you will see this pop-up from the browser asking me to provide the right username and the password. So it is test and test. So just type it here, test and test. And we see that we can access the application after providing the basic auth. So this is just the beginning of what the module can do for you. You can also customize it the way you want. Every middleware, every rule is configured in a way that you can basically customize or disable any of them that you do not need, or basically case of your application, certain policy might not work. There are also the section about good practices, which covers things like what you should, for example, return what is necessary. So basically about sanitization, about using security, S-link plugins, activity logging, many other stuff. So I highly recommend you to check it out, both the internal functionalities of the module and the good practices, to learn more how you can make your application more secure. Okay, so let's go back to the presentation. And actually, that will be it from what I prepared for you today. Thank you very much for being with me today. I hope you learned something about security and Nuxt security as well. If you'd like to find me, make sure to check the @JacobAndrewski on Twitter, YouTube, or Dev2. I'm mostly active on Twitter. So if you'd like to talk about security, talk about Vue, Nuxt, or any other things that I talked about today, make sure to drop me a message and we can talk about stuff and maybe build something together. And there's only one difference. At GitHub, my name is Barosian. So if you'd like to find me there, make sure to use that. Thanks and see you next time.